Here we're going to practice doing the analysis we've discussed so far, and that is finding x and y intercepts, holes as ordered pairs, equations for vertical asymptotes, and horizontal asymptotes, if any exist. We're also going to classify the x-intercepts and vertical asymptotes as having even or odd multiplicity, which is going to help us with our graphing. So let's begin with example 1. The first thing we want to do is we're going to find those intercepts. So to find the x-intercept for any function, that means we need y equals 0. In this case, it's a fraction, so we want the numerator to be equal to 0, but we need to be careful that the denominator is not equal to 0 so that those values will be part of the domain. Here, 1 is 12 equal to 0. That's never true, so we have no x-intercepts. Next thing, let's try to find the y-intercept. To find the y-intercept of a function, you're going to let x equal 0. So we're going to evaluate f of 0. F of 0 for this function is 12 over 0 squared plus 4, which is 12 over 4, which is 3. So we are going to write that y-intercept as an ordered pair, which is 0, 3. That's our y-intercept. Next, let's look at vertical asymptotes. So we'll have vertical asymptotes at values that make the denominator 0, but the numerator not equal to 0, or more explicitly, we want factors that we cannot cancel out from the denominator. In this case, x plus 4 is the denominator that has no real zeros. So we have no vertical asymptotes. And holes occur at common factors between the numerator and the denominator. So we have none. There are no common factors here. And the last part of the analysis, let's find the infinite asymptote. So far we've only talked about horizontal asymptote. So the degree of the numerator is 0. The degree of the denominator in this case is 2. So this function is bottom heavy. And when a function is bottom heavy, that means as x goes to plus or minus infinity, this function is going to approach the line y equals 0. Example 2. We'll begin again. Let's find our x-intercept. So our x-intercept occurs when the numerator equals 0, but the denominator is not equal to 0. And I'm going to factor this. It's usually a good thing to do when we start analyzing rational functions. So the denominator is a difference of squares, which factors as x plus 4, that quantity times the quantity x minus 4. So the numerator equals 0, and the denominator is not equal to 0 when x equals 0, right? 1 is 3x squared equal to 0. So that means we have an x-intercept at 0, 0, and the multiplicity is even because the factor that gives us the 0 at 0 is 2, which is an even number. Next, let's find the y-intercept. Y-intercept for any function, let x equals 0. So we need to evaluate f of 0. In this case, that's going to be 0 over 0 minus 16, which is going to be 0. So the y-intercept is 0, 0. Whenever we have an x-intercept of 0, 0, we will also have a y-intercept of 0, 0. Okay, vertical asymptotes, next thing we want to find. Vertical asymptotes occur when the denominator is equal to 0, but the numerator is not equal to 0, or more explicitly, when the denominator, 0 of the denominator is greater, has greater multiplicity than that corresponding 0 in the numerator. Here, the denominator is 0. We have two factors, x plus 4 and x minus 4, which means we're going to have vertical asymptotes at x equals negative 4 with odd multiplicity, right? This has a multiplicity of 1, and x equals 4 from the factor of x minus 4 here, also with odd multiplicity. And the multiplicity we're going to talk about soon. It's going to help us with our graphing. Holes occur when we have common factors in the numerator and the denominator. In this case, there are none. There are no common factors between numerator and denominator. So I'm going to write no common factors in numerator and denominator. And the last thing we want to find is horizontal asymptote. Do we have one for this function? In this case, the degree of the numerator is 2, and the degree of the denominator is 2. So we have the same degree in the numerator and the denominator. So the horizontal asymptote is going to be at the ratio of the leading coefficients. So the leading coefficients for this function are 3 and 1, 3 in the numerator and 1 in the denominator. So we're going to have a horizontal asymptote at y equals 3 over 1, or simply y equals 3. Number 3. We're going to go through all the steps again. So I'm going to go ahead and factor this as x plus 3 times x minus 3. These are both difference of squares. So let's find our x-intercept. X-intercepts occur when the numerator is 0, but you have to check to make sure that those values are in the domain. So the denominator better not be 0 there. So we have two x-intercepts here, negative 3, 0, and 3, 0. And both have odd multiplicity. Next thing, let's find the y-intercept. So the y-intercept, we're going to evaluate f of 0. It's easier to look at the unfactored form. So this is going to be negative 9 over negative 4, which is 9/4. Always write that y-intercept as an order pair, so it's going to be 0, 9/4. Next thing we want to look at is vertical asymptotes. So vertical asymptotes occur when the denominator is 0 and it has that 0 has higher multiplicity in the denominator than the numerator. So I'll just put numerator is not equal to 0, but you know that also means it just has to be higher multiplicity in the denominator. So here we're going to have two vertical asymptotes, x equals 2 and x equals negative 2, both with odd multiplicities because these factors both occur once, x plus 2 and x minus 2 in the denominator. Wholes will occur when we have common factors in the numerator and the denominator. There are no common factors here, so there are no wholes. And finally, horizontal asymptote, we're going to look at the degree of the numerator and the denominator. So here the degree of the numerator is 2. That of the denominator is also 2. Right? Both of these have an x squared term. So the horizontal asymptote is at the ratio of the leading coefficients. Both leading coefficients of the numerator and the denominator are 1. So we have a horizontal asymptote at y equals 1. And last example. Let's go ahead and factor this. So x squared plus 4x plus 4 is x plus 2 squared over x plus 2. Let's find the x-intercept. X-intercept, we want to look at when the numerator equals 0, but the denominator is not equal to 0. We need to make sure that any values that we get are part of the domain. So in this case, there are none because x plus 2 would give us a 0 at negative 2, but that is also a 0 of the denominator. Okay, so we want to remember negative 2 is not in the domain, so it cannot be an x-intercept, which means when x equals negative 2, we're either going to have a vertical asymptote or a hole. Let's go ahead and look at the y-intercept. So the y-intercept, we're going to evaluate f of 0. It's easier to look at the original function that we didn't factor. So this is going to be 4 over 2, which is 2. So the y-intercept is the order pair 0, 2. Let's go ahead and look at vertical asymptotes. So vertical asymptotes are values that make the denominator 0, but those zeros have to have greater multiplicity in the denominator than the numerator. So here we do have the factor x plus 2 in the denominator with a multiplicity of 1. That factor x plus 2 has a higher multiplicity in the numerator than in the denominator. So this function is not going to have a vertical asymptote. Instead, it's going to have a hole. So holes occur when the zeros have greater or equal to multiplicity in the numerator than the denominator. So we can actually simplify this function. This is going to become x plus 2, where x is not equal to negative 2. So because we can cancel out the factor x plus 2 in the denominator, we're going to have actually a whole with an x value of -2. And then to find the y value, we need to use the simplified expression. Okay, that's the key. Use simplified function. If you don't substitute -2 into the simplified function, you're going to get 0 over 0, which is undefined. So the simplified expression is x plus 2. So we're going to put -2 in. So -2 plus 2 is 0. So we have a whole at -2, 0. And the last piece of the analysis is we need to find out if we have a horizontal asymptote. So here, the degree of the numerator, so I'm going to say n is 2, little n is 2, and the degree of the denominator is 1. So this function is top-heavy. If it's top-heavy, it has no horizontal asymptote. And in our next lesson, we're going to learn, in this case, we're actually going to have a slant asymptote.